Welcome to The Invisible Architect, a video exploring how the quantum realm shapes our reality. We'll look at quantum tunneling, wave interference, and the subatomic rules governing biology, chemistry, and modern technology. At the smallest scales, matter is described by wave functions, derived from the Schrödinger equation. These functions map where a particle is likely to be found, treating electrons not as solid dots, but as, quote, clouds of probability. In classical mechanics, an object needs sufficient energy to climb a hill. However, in the weirdness of quantum mechanics, a particle can tunnel straight through a potential barrier, keeping its total energy exactly the same. In chemical reactions, classical models require particles to overcome an activation energy. The quantum tunneling model allows low-mass particles, like protons and electrons, to pass through classically forbidden regions. Consider the case of hydroxymethylene. Attempts to detect it failed because it rapidly decayed into formaldehyde via quantum tunneling. This proves the phenomenon occurs even within the smallest water droplets. Quantum biology suggests that biochemical processes involving proton transfer are actively facilitated by quantum tunneling. Hydrogen, being the lightest element, has the highest probability for this tunneling to occur. The smoking gun proof involves deuterium, an isotope of hydrogen with twice the mass. The transfer rate for deuterium is significantly reduced, exactly matching quantum predictions, confirming the reliance on tunneling. Quantum tunneling can also cause genetic mutation. During DNA replication, a proton can tunnel across the double helix, creating a rare tautomeric form. This accumulation of mutations over time is hypothesized to drive biological aging. According to the de Broglie wavelength, quantum physics asserts that the electron is a wave. Because matter has a wave nature, particles can undergo reflection, constructive interference, and destructive interference. Nature actively uses optical wave interference. The brilliant blue of the Morpho butterfly is not produced by pigment, but by physical nanostructures that cause reflection and interference of specific light waves. Inside any crystal, the positive nuclei of atoms create a highly regular, repeating electrical potential. This acts as a microscopic structural grid guiding electron waves through the material. As electron waves move through this regular potential, they reflect off the internal structures. For certain wavelengths, this reflection causes destructive interference, meaning they cannot propagate inside the crystal at all. This inability of certain electron waves to propagate through the atomic lattice creates a, quote, band gap. A band gap is a strictly forbidden energy zone, where electrons are physically disallowed from possessing energy levels due to wave interference. The size of these quantum band gaps dictates our modern world. Metals have overlapping bands allowing free flow. Semiconductors have a narrow gap, forming the basis of all computer chips. Insulators have a massive gap, preventing electron flow. Quantum mechanics governs our reality, from the tunneling protons driving biological aging to the wave interference that colors nature and powers our microchips. Quantum rules are truly the invisible architects of our macroscopic world.